So this is going to be my second video on this worksheet, and I just want to emphasize how amazing Desmos is, all right? And I want you guys to use Desmos right now as we make this recording here. So the first part of the worksheet says list all the possible rational zeros, okay? So this is using the rational root theorem, Now, this was very, very, very effective back when I was in high school, back before we had graphing calculators or Desmos or the internet or electricity. I'm just kidding. We had electricity. But anyway, yeah, nobody laughed. Cool. Let's review how to find all the possible rational zeros using the rational root theorem. And what you do is you take all the multiples of the constant. So I'm going to take the multiples of the constant, which is 2, over the multiples of the leading coefficient, which is 6. Now, this is the way I do it. This is how I do it. Like, this is not really a fraction, but I draw like a fraction bar, even though it's not really a fraction. And I put the multiples of the constant 2. How could I get 2? Well, 1 times 2, okay? And how could I get 6 on the bottom? I could get 1 times 6 or 2 times 3, okay? Now, again, this is just the way I get organized to make a list of all the possible answers, okay? So I recommend you do the same method if you want, but this is not a fraction. If you're in a different math class, a teacher says, well, what the heck is that? Is that a fraction that says 12 over 1,236? No, it's not. This is just a method of me getting organized, all right? And what I do is I pick a number like the numerator 1. It's not a fraction, so let's not call it a numerator. I take the number 1 and I take turns putting it over the 1, 1 over 2, 1 over 3, and 1 over 6. That's what I do, all right? So let me actually do that. So there it is. I put the 1 over each and every one of those blue numbers below. And now I'm going to take the 2 and I'm going to put it over each of those blue numbers below. Do we understand that, what I just did right there? Now, of course, the rational root theorem has it as plus or minus p over r. So yes, at the end of it all, when I make my final list, I'm going to put a plus or minus in front of each of those possible answers. So what I do is go through each one of these and see if there's any repeats, because you don't need to write it twice in your list. This is really 1. I'm going to put plus or minus 1. Okay, this is really 1/2, plus or minus 1/2. This is really 1/3, plus or minus 1/3. This is really 1/6, plus or minus 1/6. This is really 2, the number 2, so I'm going to put plus or minus 2. This 2 over 2 is really 1, so I'm just going to scratch it out because I already have 1, so it's pointless for me to write it again. Okay, and then we have 2/3, and that's not on our list yet, so let's put 2/3 with a plus or minus in front of it. And last but not least, 2 over 6, that reduces down to 1/3, and we already have 1/3 up there, so I don't need to worry about that last one. So ladies and gentlemen, when I say make a list of all your possible rational roots using the rational root theorem, this is my list right there. That's my answer. We will have 1 or 2 of those on the test tomorrow. Why is this important? It's really not. If you have Desmos, you will be able, I mean, this is kind of irrelevant, right? But if you have Desmos or a graphing calculator, you could just graph it, find your x-intercept. That is a rational answer right there. That makes sense. And you could use that actual answer on the x-intercept from Desmos to be able to do synthetic substitution, to be able to create a depressed polynomial and work from there. So when is this effective? Why the heck do we even learn this? Well, if you did not have a graphing calculator, or if you did not have Desmos, then this is great, because then from here you could pick, like, I'm going to pick the number 1 and I plug it in, and if it gives me a remainder of 0, then yes, I know that 1 is an answer. If it didn't work, if it didn't give me the output of 0, then I'd have to plug in a different number, maybe like -1 instead of +1, see if it gives the output of 0. And if that doesn't work, then you go for another number like 2 or -2. So rational root theorem, plus or minus p over r, is great when you don't have Desmos, when you don't have a graphing calculator. But since you do, it's kind of irrelevant, but I'm still going to give you 1 or 2 questions of these, and I hope you're able to come up with this list. Let's move on to the next section of the homework yesterday. It says find all the rational zeros. Okay, find all the rational zeros. Now, if you didn't have a graphing calculator, if you didn't have Desmos, you would have to create this list using plus or minus P over R, the method that we just did. Then you would be guessing and checking to see which one actually gives you the output 0, and you would be able to say, oh, that's my answer. But since we have Desmos, all we do is take this P of X function, and you could type it right into Desmos, right? Now, let me show you how you would type that into Desmos. I already typed it in. I already see my graph right here. But let's go down to the keyboard right here, the keypad. So you have your numbers and your math symbols right here, which I'm sure you guys are comfortable with. And right here we have our variable X, our variable Y. This button right here, the a to the second, that's like if you type in X and you want to put X squared, the quick way to do it is to just hit a to the second. X squared, boom, X squared. Now let's say you wanted to type in X to the third, or X to the fourth, or X to the seventh. Then you would hit X, and this button right here, the A to the B power, this button will raise the cursor from your regular number up to the exponent position. Does that make sense? So again, let's say you wanted X to the fifth, you would go X, hit this button, and then you would hit the number 5, okay, X to the fifth. All right, so that's what I did over here. I typed in X, I typed in the B to the A or A to the B button, and then I typed in the number 3, and then minus, and then X, and then the square button, and then plus X minus 1, and voila, it graphs for you, okay? So going back to our instructions, it says find all of the rational zeros. Now this is very important, guys, that we emphasize this word rational. What does rational mean? Rational means numbers that make sense, right? Like -3, like +5, like 1/2, like 0.75. All of those decimals and numbers, they make sense. You know what 75 cents is, right? Now, those make sense. What are decimals that don't make sense? I would say like pi. Pi is crazy, 3.14, and it continues on forever. There's no pattern. There is no ending to it. Likewise, any square root of a non-perfect square number is a crazy irrational decimal. Like the square root of 7, it goes on forever. There's no pattern. It doesn't repeat, right? Those are irrationals. Now, the instructions say find all the rational zeros. Just find the answers that make sense, which clearly, when you graph it, if you see an x-intercept, you'll be able, well, yeah, this makes sense right here. That is the value of x equals 1. And that's the only place where this crosses the x-axis, which means that that's the only answer, the only rational answer, x equals 1. Now, it would be a different story, ladies and gentlemen, if I told you find all of the answers. Right here it says find all the rational answers, but if I said find all of the answers, then you would have this one real answer, but you know it's a third degree function, so you need to find those other two answers that are not rational or not real, actually, because there is no other place where it crosses the x-axis, which means that the other answers must be imaginary. Does that make sense? Okay, so how would you do that if I asked you for all of the answers? If I asked you for all, you would plug in the number 1 right there, and then you would plug in you would write your coefficients, 1 on x to the third, -1 on x squared, 1 on x, and -1 as a constant. And you would go down 1. As you go up, you multiply. 1 times 1 is 1. As you go down, you combine. -1 plus 1 is 0. As you go up, multiply. 1 times 0 is 0. As you go down, combine. 1 plus 0 is 1. As you go up, multiply. 1 times 1 is 1. As you go down, combine, which gives you the output 0. Which makes total sense because we already knew that this was an answer. So why would I do this? Because if they did ask me to find all of the answers, now the instructions here just say find the rational answers, the one that makes sense, and the one that makes sense is x equals 1. The other ones will be imaginary. Now, as you can see, I plugged in 1. I could get my depressed polynomial from here, the constant 1, 0x, and 1x squared. So these blue numbers give me a depressed polynomial function of x squared plus 0x plus 1. And that is a factor, which means that if I did zero product property on the factors, you'd have to set that equal to 0 and solve. So you'd subtract 1, giving you x squared equals -1. You'd have to apply a square root. X equals plus or minus I as your final two imaginary answers. Now, I did not ask you to do this on this section. All it's asking you for are the rational answers. So instructions are very, very important, okay? If the instruction says find all of the answers, well then yeah, graph it, find that one real answer, that rational answer, use it to find the rest of them, right? But right here the instructions just say, just find the rational answers, the one that makes sense. These are imaginary, that's not rational. So this is the only one that's rational, that's the only x-intercept, you're done. So this entire homework assignment is really pretty much practice for you to get comfortable with Desmos. If you type in number 13, 2x to the third plus 7x squared plus 7x minus 12 correctly, and you graph it, you could even touch the screen at these locations and it'll give you the actual coordinates of the x-intercept. So you could clearly see that your answer is x equals -4, x equals -1, x equals 1.5. Now, instead of decimals, normally on the multiple choice, you're going to see fractions. 1.5 is really 3/2. $3 divided by 2 is $1.50. So you have these three rational answers. They make sense. We understand them. They're not crazy decimals. They're not imaginary. These are nice rational answers, and that's all they're asking for on number 13. So number 13, your answer is x equals -4, x equals -1, and x equals 3/2. Ladies and gentlemen, let me ask you a question. Hopefully we all understand this, but let me ask you a question. Is it possible, even though we found the rational answers, is it possible that this g of x function has other answers, maybe like imaginary answers, or maybe like irrational answers, like with square roots? Is it possible? A lot of you are saying yes, but the answer is no. Why not? Ladies and gentlemen, what's the degree on this function? What's the degree? The degree is 3, right? The degree is 3. What does that mean? That it could at most have 3 answers, at most, right? And what do we have here? We actually have 3 rational answers. That's at most. So there absolutely is no other possible answer that's imaginary or that's irrational, right? Like that's it. You got 3 rational answers. That's the most answers you could possibly have. Now, if this graph would have only crossed right here at -4 and it wouldn't have crossed anywhere else, just there's a line that crosses at -4, then you'd have -4 as an answer, then yeah, for sure, you could have 2 other answers that are both imaginary or maybe 2 other answers, so I hope we understand that, because I could give you some questions like that for you to think about. Like, if your degree is 3, the maximum amount of answers you could have is 3, all right? So if we flip it to the second page, continue to find rational zeros. That's easy. Just type it in carefully, because sometimes you type in a minus instead of a plus. Type it in carefully. You should be able to see those answers, right? Right here we have, I forgot to highlight that one. That's x equals -1. We have x equals 1/4. We have x equals 3/4. We have x equals 2. Those are our 4 answers, 1 negative, 3 positive, to this 4th degree polynomial function. It cannot have any other answers. You already have your maximum amount of answers there, okay? Things to know. So those were questions that had the instructions find the rational answers. So even if I had a 4th degree equation, and if I graph it and it only crosses at one spot, then that means that there's only one rational answer, and then the other ones are going to be imaginary, or but there's only one real answer if it only touches that one spot. So be aware of that. If I ask you, like the instructions say down here at the last part of our homework, to find all of the zeros, it doesn't say find all the rational zeros. Rational zeros are answers that make sense, like 3, like -2, like 1.5, like 0.75. All those make sense. But down here it says find all of them, right? So we've already done number 24. I just want to reiterate. We have g of x. Because we have Desmos, type that in. You will see that it crosses. Actually, it doesn't cross. It just touches at x equals -2. So this is something interesting that we need to understand as well. If a graph crosses through, let's say -8, then your answer is -8. But if it just touches, if it goes down and touches and comes back up, that kind of looks like a parabola, right? Which would kind of be like an x squared, which means that this answer of -2 must have a duplicity of 2 at least, right? So this x equals -2, you could probably use it 2 times, right? So that's what we do. We take that answer, x equals -2. We know it's x equals -2. We use -2 for synthetic substitution. And of course it's 0 because the answer is -2. But we take this depressed polynomial coefficients and we rewrite them and we plug in -2 again because it touched. Because it touched, we know that it's going to work a second time. So we plug in -2 again with the depressed polynomial coefficients, getting 0 again. That proves that it works twice. And now at this point, I have the constant, I have 0x, and I have x squared. That's a quadratic that I could actually solve, subtracting 1, square rooting, giving us a final answer of x equals plus or minus I. So here are our other 2 answers. So we have one answer, x equals -2. We have the other answer, x equals plus or minus I. That is a total of 3 answers. But this was a 4th degree polynomial, which makes sense only because we saw that the answer -2 had a duplicity of 2. So you really did have 4 answers, but it's actually written down as 3 answers, right? You have positive I, you have negative I, and you have -2 and also -2, but you just write it once, right? Maybe in the future I'll ask you to write down the answer and the duplicity if they have any. But right now, all you got to do is write down those 3 answers, positive I, and -2. Okay, so it is possible for a 4th degree equation to have only 3 answers or only 2 answers, right? But there's going to be some duplicity in those answers. It's not possible for you to have more than 4 answers on a 4th degree polynomial function. Would anybody like to see any of these? I asked you to try to do this homework, and I hope you guys have some questions that we could clarify right now. Ladies and gentlemen, since nobody had questions, I'm assuming everybody's ready for the test. Good luck.